MCAT questions around a minute, part 16. Let's go. A cell uses a sodium glucose importer to transport glucose into the cell. The transporter relies on the sodium electrochemical gradient and does not directly use ATP. When extracellular sodium levels are decreased, glucose uptake into the cell falls. Which of the following changes would most directly increase glucose uptake under these conditions? To start, it's important to notice that the question mentions it does not directly use ATP. This, as well as the details in the question, are clear indicators of secondary active transport. But what is secondary active transport and how is it different from primary active transport? Here's an explanation given by the Miles Down review sheet. If you're studying for the MCAT, you should definitely download it. Essentially, what it's saying is that primary active transport directly uses the energy from ATP hydrolysis to move molecules across a membrane against their electrochemical gradient. Secondary active transport, on the other hand, uses the energy stored in an electrochemical gradient created by primary active transport to move another molecule against its electrochemical gradient. So essentially, one molecule goes up its gradient, the other goes down. The two types of secondary active transport are symport and antiport. So let's go back to the question. A is wrong because remember, secondary active transporters don't directly use ATP. They use the electrochemical gradient created by primary active transporters, such as the sodium-potassium pump. But remember, the question is asking which of the following changes would most directly increase glucose uptake. B is wrong because more glucose does not matter if there's no driving force, which is created by sodium's electrochemical gradient. D is wrong because the sodium-potassium pump maintains the sodium gradient, and inhibiting it would collapse the gradient even more, making glucose uptake decrease further. And C is correct because it strengthens sodium's electrochemical gradient, particularly by increasing the membrane potential.